All right, great. Hi, everyone. My name is Evan Pedromo, and I'm here with my colleague Milan Gruner. We're from the Open Earth Foundation. Open Earth Foundation is a nonprofit established to make open source software to fight climate change. And we're here to talk about CityCatalyst, which is our flagship product for building greenhouse gas inventories for cities.
Right. So, first off, what is a greenhouse gas inventory? Basically, it's a climate accounting tool that allows you to catalog all greenhouse gas emissions within a city, at least in our case. It's sorted by the different sectors and subsectors, different gases as well, the different scopes, so inside or outside of the city boundary. And it's basically a list of highly modeled emissions, highly modeled estimates of emissions that are based on activities that are occurring within the city. All of this is defined by a standard specification called the GPC, or the GHG Protocol for cities. All right. And why all of this matters at all is the only way we can really reduce the emissions worldwide is by reducing the activities. And this emissions inventory that we are creating here allows the city to know where they could apply the funding best and fund new programs in order to reduce them. Really, there's no point in investing in reducing emissions from sources that barely affect your city, so it's really good to know where you want to focus your resources. Emissions inventories also are a necessary first step for cities to get financing for climate action, so they're really important in that regard.
I'm just going to take the mic and you hold the clicker. So, as we said before, about 70% of worldwide emissions come from cities. So very high amount of our worldwide emissions come from cities, but only 5% of cities have a published greenhouse gas inventory. And that's because it's challenging to put together a greenhouse gas inventory to obtain the data necessary to publish information for all the different sectors, whether they're stationary energy or transportation, wastewater, agriculture, or industrial. It also takes a lot of skill and time to put together these systems, be able to derive the necessary outputs from the input data. Good? You want me to do it?
Yeah, I've got it.
Oh, okay.
Here you go. All right. So, what we are doing here to overcome it is we built a web app to allow you to create GHG inventories. Yeah, this is a web front end, basically a shared repository for inventories and also for user data that can be used for collaboration. It's also a data warehouse for GHG-related data organized by city. And we have a separate so-called global API that makes it easy for this web front end to import only the relevant data, so only for your specific city, let's say, as well as a guided input system that can be used, you can see it here, if there's no third-party data available and you need to enter the data that you get from, let's say, your energy companies and so on manually. Cool.
Why don't you do this one?
Cool. So for the implementation, we have built this using a bunch of different open source libraries. So for instance, it is built on React, TypeScript, it's Next.js. For the UI, we're using Chakra UI. In the backend, it's using a standard Postgres database, and then the SQLize ORM to connect to it. Also, we're using Auth.js to make the authentication easier and standardize it. And then smaller libraries like Nevo for charts, Pigeon Maps for the city map, Sort for validation, I18 Next for internet serialization, because this is already available in 3 different languages. And in the backend, let's say Decimal.js in order to have precise calculations. The backend itself is also part of the same Next.js application in order to facilitate the sharing of type definitions and also functionality with the front end. And the separate global API that we built for accessing data sources that is there that different CityCatalyst instances can connect to. It's built on Python, Fast API, the Postgres database again, and the PostGIS system, so we can have geometric primitives on the globe. Then the last part is the data pipeline that imports all of our huge data sources. That's built using Python, Pandas, and MageAI, and it processes those data sources into the GPC standard so it can be grouped by individual cities.
And what we get out of that is a mechanism that makes it very easy for even untrained city personnel to put together their first climate inventory. We're doing a first pilot project in Brazil with 50 cities in Brazil. They're putting together their first GHGIs, or first greenhouse gas. Oh yeah, thanks. First GHGIs, thank you. First GHGIs, first climate action plans, as well as climate change risk assessments using the CityCatalyst platform. We collaborate with local consultants in order to identify relevant data sources, but that we bring them into the platform to make them publicly available to any city. And we are planning to expand this program in Brazil and also bring it to other cities around the world.
All right, and we are using an open source. We are an open source repository, so you're all welcome to contribute. First off, of course, just creating issues on GitHub helps, reporting bugs, proposing features. You can open pull requests in case you're familiar with TypeScript and React and want to help out, or just reach out to us, give us feedback, let us know where you would like to use this. This QR code leads to our repository, but it's also linked in the in the talk information. All right. Any questions? Thank you.
You want to take questions?
Sure.
Where did you get the data from? Because by experience, it's already hard enough to get it for a single building, let alone a city.
Yeah, so we are using a lot of remote sensing data, particularly satellite information. So the satellite regularly takes screenshots or like photos of areas, and then you can sort of estimate by the amount of smoke that is coming out of a factory, let's say, how much emissions there could be. So we're using a lot of open data sources that can be made available to the city there.
But the data sources really vary widely. We can use data that's based on fuel sales within the city, right? And we can use that in order to estimate how much fuel was burnt for different processes. We may have industrial data. We do use satellite data for things like agricultural changes, right? So if crops have changed or forests have been deforested, we can actually detect that with satellite data. We don't do a lot of that data work ourselves. There are a number of really great projects like Climate Trace, the IEA publishes data, Edgar publishes data. We tend to take that data and chop it and slice it so it works for the individual cities. Great question, though.
Thank you.
Yes, in the back. What kind of entity? Yes, sure. The question is, what kind of entities are using CityCatalyst right now? Yeah, so I think I had it in the previous one. We're working with a pilot project in Brazil with the Brazilian government and 50 cities in Brazil. I know that there are other users around who are doing pilot projects, but we don't have tracking, so we're not exactly sure who else. Is that a fair answer? Yeah, I think our target audience is really city governments or consultants in the climate space. Yes.
Greenhouse gas emission inventories, are they about the greenhouse, like literal greenhouse gas produced in the city, or also what's produced as a result of economic activity in the city?
Yeah, so that's where it really breaks down by scope. Yeah, sure. The question is, are greenhouse gas inventories just about the gases that are emitted within the city, or does it cover economic activity within the city also? And the answer is yes, it covers economic activity that happens within the city. There are 3 scopes that we call them. Scope 1 is for fuel that's burned within the city. Scope 2 is for energy that's used from power generation, and then scope 3 is for economic activity that happens outside the city. That's it for us. Thank you very much.